Okay, so for initial setup for this lab, we're going to need LabQuest device, variable load, an energy sensor. So these are two different sensors, energy sensor, variable load. We're going to need a wind turbine. So you're going to want to grab a wind turbine, fan, and of course our iPad. So that's what we need for initial setup. So for this lab, I already have everything hooked up that you're going to need to hook up. So let's follow along. I've got my energy sensor hooked up to my LabQuest, so there should be two plugins for your energy sensor. Should be getting a reading something like that initially. And then you're going to want to grab a couple sets of alligator clips. And so I hooked up my energy sensor to my variable load using a black and a red alligator clip. Make sure to plug it in black to black, red to red. And make sure these are nice and tight once you've actually plugged this in. So you're going to plug metal on metal and make sure it's in there nice and snug. And then on the other side here, for our source, I took another set of alligator clips and I plugged these right onto the metal end of our turbine. So again, you're going to hook up the turbine using alligator clips to the energy sensor, red to red, black to black. So this is a overview of my whole setup when everything is hooked up. So here should look something like this. I've got my fan plugged in already, and I have it set to a certain distance from the wind turbine. As long as you keep your distance consistent, measuring it out won't matter. So just make sure it's a appropriate distance away from the wind turbine, which you might have to adjust anyway once you hook up your propellers. So the next thing that we're going to do is calibrate our LabQuest to find maximum power before we run our different sets of variable choose your own trials. So I'm going to go to my box of wind turbines here and I'm just going to grab one at random. Don't take this whole setup to your lab station because I've only got, a certain amount of wind turbines for the whole class. And so now I'm going to hook up the initial one that I grabbed. Again, it doesn't really matter which one you use to find your max power to calibrate, but you are going to want to write that down in your lab sheet. So once I've got all this hooked up, I'm just going to turn my fan on. I would turn it on high, but again, as long as you're consistent, as long as the distance between the propeller and the fan is consistent, and as long as your speed is consistent, it shouldn't matter. So pick one and stick with that. So this is going. If yours is having trouble getting going, just give it a little flick. It might take a little bit to get going. Mine went right away, it looks like, which is good. So this is already spinning pretty nice. So this is the part where we're going to fill out this data sheet and we're going to try to find our max power. And so the way we would do that here is by adjusting the variable load. And so this first column here is asking to set the resistance to 10 ohms. So we're going to pay attention to the resistance down here, and I'm just going to move this. You got to be careful to move this very subtly. Looks like mine already shot up. And again, this is so fine that I'm going to call this good. So about 10.4 for resistance. And so I'm going to go into my data sheet here. And so for a resistance of 10 ohms, I'm going to write down my potential current and power. And so you're just going to keep going. You're going to keep adjusting the resistance here. Next one is asking for 20. Again, this is really fine. I would call this good for 20. And you're just going to record, again, potential current and power. And you're going to go up, so 20, 30, 40, 50, 100, and 150. And so what we're searching for here is which of these settings is going to give us the greatest power reading. Something to be aware of too, if I'm standing behind the fan here, or if you have big large obstructions behind your wind turbine, you can cause a little bit of resistance in your airflow. And so you want to make sure that the area, your lab area for this lab, is as free flowing as possible. You don't want a lot of obstructions, behind or on the sides of your wind turbine here. Another thing really quick here too, sometimes you can get such a strong gust of wind that it actually moves your turbine. So as I was talking here, looks like my wind turbine moved a little bit. So you could either readjust this, but probably what that's telling you is you're going to want to move your fan away a little bit. Okay, so the idea here is that now that we found the max power, you're not going to want to touch that variable load for the whole rest of the experiment. So part 2 of the experiment is going to be kind of a choose your own adventure. You're going to be choosing 2 of the options below. So on page 2 here, I've got a few different options that you can choose from for this experiment. So not everyone is actually going to be doing the same experiment. So some of the options include blade area, blade pitch, blade quantity, blade mass. I also left an option to choose another experiment if you have a fun idea that you think you want to try. Maybe check with your instructor for that one, but you can definitely do one that's not included in this list. So for example, what I'm going to do is grab 4 blade types that only one variable is changed in. So I chose blade pitch for my first experiment here. So I grabbed 4 blades that have different pitches. So pitch 30, pitch 50, I've got a pitch of 10 degrees and a pitch of 20 degrees. So the one thing with these variables, like I said, I picked pitch. So I have 4 blades with 4 different pitches. You want to be consistent with everything else. So you could choose, one that has a pitch of 10 degrees and a pitch of 20 degrees, but if the blade length is different for the 20 degree one, that's not a good experiment because you have too many variables. So I want to make sure that the area, the weight, and the length of all of these are the same, and the only variable that's changed is the pitch. And so that's the case for everything. If you choose blade length, you need to have 4 different blades of different lengths, but the pitch should be exactly the same. You should have a pitch of 10 degrees or 15 degrees for blade length. Everything should be consistent except for the variable that you're testing. And I'm going to run a trial using each of those. So if I go back to the table here for a second, my variable is going to be pitch. And then what you're going to be doing is finding the power at each pitch. So my pitches were 10 degrees, 20 degrees, 30 degrees, and 50 degrees. So I'm going to attach each one of those blades to the wind turbine, and I'm going to run a separate experiment. So a 10 degree experiment, a 20 degree experiment, 30 degree, and 50 degree. And I'm going to find the power. So you're just looking for power here. And then what I'm going to do after that is actually plug this into graphical analysis. So we can go to graphical analysis. Manual entry. And I'll show you how to do this really quick. We've used graphical analysis quite a bit in this class. But if I go to column options, in this case, my X is going to be pitch. My unit is going to be degrees. Column options. And this is my power. Power is going to be in milliwatts. And so you're just going to graph your data in here. As always, let me know if you have any questions filling out the lab write-up. This was our wind power lab. Thanks for watching.